At the edge of observable space, 13 billion light-years away, something is wrong. Galaxies are behaving in ways they shouldn't. Patterns are emerging that our theories can't explain. And the more we look, the stranger it gets. We might be witnessing the breakdown of physics itself. I need you to understand something before we go any further. What I'm about to show you isn't speculation or conspiracy theory. This is data from the world's most powerful telescopes, analyzed by leading cosmologists, published in peer-reviewed journals. And it's breaking our models of reality. The universe, at its largest scales, isn't behaving the way our theories predict. Structures that shouldn't exist are there. Patterns that should be random aren't. And physicists are starting to ask a terrifying question: what if everything we think we know about the cosmos is wrong? This is Hubble Videos, and today we're diving into the mystery at the edge of existence. To understand what's going wrong, you first need to understand what's supposed to be right. According to our best cosmological models, the universe should have a specific structure. After the Big Bang, tiny quantum fluctuations in density were stretched to cosmic scales. Denser regions attracted matter through gravity, forming a vast cosmic web, filaments of galaxies stretching across hundreds of millions of light-years, separated by enormous voids. It's beautiful, really. The universe organized itself like a neural network, with galaxies as nodes and dark matter filaments as connections. From chaos came structure, from randomness came pattern. And for decades, observations matched predictions perfectly. The cosmic microwave background radiation, the afterglow of the Big Bang, showed exactly the fluctuations our models required. Galaxy surveys revealed the cosmic web we expected. Everything made sense. But then we built better telescopes. We looked farther back in time to the universe's first billion years. And that's when the cracks started showing. Picture the James Webb Space Telescope floating 1 million miles from Earth, its mirror unfurling like a golden flower. Its infrared eyes can peer through cosmic dust, detecting light that's been traveling for over 13 billion years. What it's seeing shouldn't be possible. In 2023 and 2024, JWST sent back images of the early universe that left astronomers stunned. Galaxies that are too massive, too mature, too organized for their age. Structures forming too quickly, patterns emerging too early. According to our models, the early universe should be messy, chaotic, primitive. Instead, it's sophisticated, organized, and eerily mature. It's like opening a history book, expecting to find cave paintings, and instead finding Renaissance masterpieces. Let me give you a specific example that keeps cosmologists up at night. JWST has discovered galaxies containing hundreds of billions of stars existing just 400 to 600 million years after the Big Bang. These aren't small, primitive star clusters. These are massive, mature galaxies that should have taken several billion years to form. Dr. Joel Leja from Penn State put it bluntly: these galaxies are so massive, they shouldn't exist. If our models are correct, there simply wasn't enough time for them to form. The process of galaxy formation requires multiple steps. Gas cools and condenses. Stars form. Those stars die in supernovas, enriching the gas with heavy elements. New generations of stars form. Slowly, over billions of years, a galaxy emerges. But these galaxies skipped the line. They appeared fully formed, like someone hit fast forward on cosmic evolution. It gets stranger. JWST and other surveys have discovered massive structures, walls and filaments of galaxies, stretching across hundreds of millions of light-years in the early universe. To put that in perspective, imagine trying to organize all the people on Earth into a single line stretching from here to Mars. Now do it in the first year of human civilization. That's essentially what the universe appears to have done. The Sloan Great Wall, one of the largest structures we've ever discovered, contains billions of galaxies arranged in a sheet-like formation over 1 billion light-years across. That's staggeringly massive. But here's the problem. These structures require gravity to slowly pull galaxies together over immense timescales. The ones appearing in the early universe shouldn't have had time to form yet. It's like finding a city on land that emerged from the ocean yesterday. The timeline doesn't work. Then there's something even more unsettling: unexpected alignments. Multiple studies have found that the rotation axes of galaxies aren't randomly oriented as they should be. In certain regions, galaxy spins are aligned with each other across distances of hundreds of millions of light years. Think about that. Galaxies separated by unfathomable distances, forming in supposedly isolated regions of space, somehow rotating in the same direction, as if they're connected by some invisible thread. There's no mechanism in our physics that explains this. Galaxies should form independently, with random orientations. Finding alignment is like flipping coins in New York and Los Angeles and getting the same sequence of heads and tails. It shouldn't happen, yet it does. So what's going on? Why are observations diverging from predictions? Scientists have proposed several explanations, and none of them are comfortable. Possibility 1. Our models of galaxy formation are wrong. Maybe stars can form faster than we think, or maybe early galaxies were more efficient at assembling mass. This would require rewriting decades of astrophysical theory, but it's the least radical option. Possibility 2. Dark matter doesn't behave the way we think. We know dark matter exists, we can see its gravitational effects, but we don't know what it is. Maybe it has properties we haven't discovered yet, properties that allow structures to form faster in the early universe. Possibility 3. Dark energy isn't constant. Dark energy is the mysterious force accelerating the universe's expansion. We've assumed it's constant across space and time, but what if it isn't? What if dark energy was weaker in the early universe, allowing structures to form more quickly? Possibility 4. The cosmological principle is wrong. This is the big one. The cosmological principle is the foundation of modern cosmology. It states that on large scales, the universe is homogeneous and isotropic, the same in all directions with no special locations. In other words, the universe looks the same no matter where you are or which direction you look. This principle allows us to make predictions about the entire universe based on observations from Earth. It's why we can trust that the physics we measure here applies everywhere. It's the bedrock of cosmology. But what if it's wrong? What if the universe has large-scale structures, patterns, or properties that vary from place to place? What if our corner of the cosmos isn't representative of the whole? If the cosmological principle fails, it doesn't just mean tweaking our models. It means we've been fundamentally misunderstanding the universe's nature. It means the cosmos is more complex, more structured, more mysterious than we ever imagined. And it means that much of what we think we know about the universe's history, composition, and fate might be wrong. These strange observations at the edge of the universe aren't happening in isolation. They're connected to another crisis in cosmology called the Hubble Tension. The Hubble constant measures how fast the universe is expanding. We can calculate it two ways: by measuring the cosmic microwave background from the early universe, or by measuring the distances to nearby galaxies today. These two methods should give the same answer. They don't. The early universe measurement gives a value of about 67 kilometers per second per megaparsec. The late universe measurement gives about 73. That's a nearly 10% difference, and it's not going away. In fact, as our measurements get more precise, the gap widens. This is a crisis. It means either our measurements are wrong, despite using completely independent methods, or our understanding of the universe's evolution is incomplete. Some physicists think the Hubble tension and the strange structures at cosmic edges are connected. Maybe dark energy isn't uniform. Maybe it varies with time or location. If dark energy was weaker in the early universe, structures could have formed faster, explaining the impossible galaxies. And if dark energy is varying now in ways we don't understand, it could explain the Hubble tension. Or maybe there's something else entirely, a new field, a new force, a new aspect of physics that only becomes apparent at cosmic scales. Some researchers have even suggested we might need to modify general relativity itself at the largest scales. Einstein's equations work perfectly for planets, stars, and galaxies, but perhaps at scales of hundreds of millions of light years, gravity behaves differently than we think. That would be revolutionary and terrifying. Then there's the most radical possibility. What if these anomalies are evidence of something beyond our universe? Some versions of multiverse theory predict that our universe has boundaries, edges where it interfaces with other universes or other regions of space with different physical properties. Could the strange patterns at the edge of the observable universe be echoes of something beyond? Gravitational influences from adjacent universes? Relics of the process that created our cosmic bubble? It sounds like science fiction. But desperate times call for desperate theories, and right now, cosmology is getting desperate. So where do we go from here? How do we solve this mystery? The answer is better data, more observations, new telescopes. JWST is still just getting started. It has years of observations ahead, and every month brings new discoveries. The Nancy Grace Roman Space Telescope, launching in the next few years, will conduct massive surveys of the universe, mapping billions of galaxies with unprecedented precision. Ground-based telescopes are getting upgrades too. The extremely large telescope in Chile, with a 39-meter mirror, will be able to study individual stars in distant galaxies, revealing details we've never seen before. And theoretical physicists are working overtime, developing new models that might explain the anomalies. Some are modifying dark matter properties. Others are exploring new types of dark energy. Still others are questioning the cosmological principle itself. Here's what's amazing. We're living through this. We're witnessing a potential scientific revolution in real time. For decades, cosmology has been in a golden age, with our models accurately predicting observations. We thought we had the universe figured out. Dark matter, dark energy, inflation, expansion. The story seemed complete, but now the universe is pushing back. It's showing us that our story is incomplete. There are chapters we haven't read, mysteries we haven't solved, physics we haven't discovered. And that's not a failure, that's exciting. Every time science encounters something it can't explain, it's an opportunity to learn something profound. The anomalies at the universe's edge aren't problems, they're clues. Breadcrumbs leading us toward a deeper understanding of reality. Science works because we're willing to be wrong, because we follow the evidence even when it contradicts our theories, because we're brave enough to admit when the universe is more complex than we thought. The astronomers studying these anomalies aren't trying to defend old theories. They're trying to understand the truth, whatever it is. That takes courage and humility. And it reminds us that the universe doesn't care about our models or our comfort. It simply is what it is. Our job is to observe, to question, to figure it out. So something strange is happening at the edge of the universe. Galaxies are forming too fast, structures are appearing too early, patterns are emerging that shouldn't exist. Is it a flaw in our observations, a gap in our theories, or evidence of something fundamentally new about the cosmos? We don't know yet, but we're finding out. Every night, telescopes around the world and in space are gathering photons that have traveled for billions of years to reach us. Each photon carries information about the early universe, about cosmic structure, about the nature of reality itself. And slowly, piece by piece, we're assembling the puzzle. We're learning what the universe really is, not what we thought it was. The edge of the universe is speaking to us. It's telling us our story is incomplete. And that's not something to fear, it's something to celebrate. Because it means there's still mystery in the cosmos, still wonder, still things to discover that will change everything we think we know. The universe is stranger than we imagined, and that makes it so much more beautiful. If this video expanded your sense of cosmic mystery, hit that like button and subscribe for more deep dives into the frontiers of science. Comment below, which explanation for these anomalies do you find most compelling? And remember, every time you look at the night sky, you're looking at the edge of the universe. And at the edge, something strange is happening. Until next time, keep questioning everything.